So hi, welcome to our Dataverse webinar series. This is the second one in the series we've been doing. I'll be talking about data management and fair data today. While it is an introduction to data management and fair data, it's not an introduction to Harvard Dataverse. So I'm going to be starting with the assumption that folks have had some kind of exposure to Dataverse software or a Dataverse repository. If not, feel free to ask a question in the Q&A. I have a colleague here who can answer as we go, and I'll take breaks throughout to kind of invite questions. There's not too many people here today, so also feel free to raise your hand and we can kind of actually answer questions if you want to. I can unmute you and we can have a bit of a conversation about anything that comes up. So to introduce myself, I'm Katie Micah. I'm a data services librarian with Harvard Library and IQSS. I work on the curation team at Harvard Dataverse. And so we help folks share research data using the repository. And then in my role as a librarian, I also help folks kind of generally across the university share data. All right, let's go ahead and hop in. So today, as I mentioned, we're talking about fair data and research data management. The idea here is to, the goal with kind of this webinar is to think about how to apply the FAIR principles to be able to share data effectively on Harvard Dataverse, and then also design practical data management and sharing strategies to meet funder requirements. A big focus recently has been on some of the recent mandates from federal agencies to require data sharing. So we'll talk specifically about some of that too. Kind of quickly, I like to sort of start off some of these sessions with a review of kind of what we mean when we're talking about research data management. Data management is the active and ongoing management of data throughout its life cycle. So managing your data includes lots of different activities related to the storage, organization, documentation, accessibility, and dissemination of data. When we talk about RDM, or research data management, we often refer to this life cycle of data. On this slide here is a depiction of that data life cycle showing how data management happens, what the activities are throughout the entirety of a research project. So you can plan for the entire life cycle from the design phase all the way through your collection and analysis, through your publication writing, your data dissemination, and archiving and reusing content. In the context of data repositories, we usually talk about kind of the later slices of this life cycle and focus more on the sharing and archiving of data. Some activities that we'll talk more about later that occur kind of in this slice, in these two slices, are sort of the actual deposit and curation of data in a repository, selecting and applying specific data licenses to use, applying descriptive metadata, writing and organizing documentation and supplementary files, and the ongoing stewardship of your research data over its useful life. And so another foundational concept that we use to describe high quality shared data is the acronym FAIR, which stands for Findable, Accessible, Interoperable, and Reusable. And I'm sure many of you have come across this several times before, but just for kind of a basic overview so we're all on the same page. The idea behind FAIR is that sharing data is more involved than simply uploading files somewhere for others to find it. It doesn't necessarily mean making all of your data freely open or publicly available. The methods that you're going to use to share data are going to depend on a lot of factors, including the size and the content of your data, mandates from the entities that fund and publish your research, and other assumptions and requirements related to the future use of your data. So when sharing it, again, it isn't sufficient to ensure that just our data is available, that it's just put somewhere. We also need to make sure that it's usable and we need it to be accessible. This means that you can obtain the data with minimal effort. So even if the data are restricted, that means that the metadata is open, so that you can review what the data set includes and can request further access if you need to. The data should be in an appropriate format using common formats and standards and controlled vocabularies where possible. This helps ensure that users can integrate a new data set with other data they might already be using. And we also need data to be well documented and have a clear usage license. The point is that upon first review, anyone kind of looking at your data in a repository can be able to determine how they could use the data and, again, accurately understand the contents that are inside that data set. And for all data, there is a balance between the researchers and the repository's responsibilities to accomplish all of this and ensure the long-term preservation, stewardship, and utility of research data. Repositories are the ones that provide the infrastructure and offer services that make it possible to share fair data, but researchers know their data really well and can best organize, structure, and describe their data. So repositories are going to do things like assign persistent identifiers, structure metadata records according to a disciplinary standard or a schema. And this is important for both humans, so you can rapidly evaluate the usefulness of a data set, and then for machines to index data sets such that they will be served to you when you use keywords to do a specific search. Repositories also do that indexing, so data can be a searchable resource. They retrieve data sets according to an open protocol that supports authentication, preserves data files and metadata, and tracks the provenance and versions of data. Researchers, on the other hand, are the ones who are clearly structuring data and are the ones that apply good data management practices, which we will talk more about today. Part of that includes documenting data and software, richly describing data using standardized metadata fields, and applying the licenses or a clear terms of use. So while repositories are mostly responsible for a lot of pieces of the different acronyms or the different elements of fair data, it's important to remember that you, again, can't simply just dump files in a repository somewhere and then call it a day. Generally speaking, there's a process of applying some structure and organization to a data set, and we call that data curation. So the encompassing work that actions that are taken in order to provide meaningful and enduring access to data. Some repositories, including us at Harvard Dataverse, offer some curation services, but the best curation is always going to be executed by someone who has an intimate knowledge of the data and of the research project. Curators can provide functional expertise and consult on how to structure information for optimal fairness, and they can often be the first reuser of your data and help point out potential issues or missing information. But researchers recording an in-depth summary of the data analysis and research project is really vital for responsible data reuse. Sometimes this can be accomplished in a related publication, but not always. And then federal funders and agencies in the United States are well, I guess globally also, but funders and agencies are increasingly emphasizing the importance of public access to research outputs. And that includes publications, but also other products like research data and software. Policies like the NIH Data Management and Sharing Policy and the more recent NSF Public Access Plan 2.0 require researchers applying for federal funding to submit data management plans detailing precisely what data they will collect, analyze, retain, and publish through the course of their project, and also how they will openly share that data with the global research community. Overall, these policies aim to promote a culture in which data management and sharing are recognized to be integral components of research projects, rather than administrative or additive ones. Importantly, we are also beginning to see increased oversight of these plans. So not only are reviews becoming more rigorous as part of the grant review process, but program staff will provide some level of oversight to ensure that outputs are actually published. And so this might mean that future grant applications could be denied if a research team had previously failed to publish their data, or year-to-year funding will be withheld if data sharing plans are not executed over the course of a grant period. So useful to keep in mind that it's important to do what you say you're planning to do. One way that to meet these sharing requirements is to deposit your research data in a data repository. And so funders are relying on the FAIR principles to identify data repositories that meet some quality standard. This list of desired characteristics that's been published aligns with the FAIR principles, but focuses more on the responsibilities of repositories to meet them. And so these resources are a great tool to help find a repository that will work well for your specific project. And throughout these slides. I have links to useful resources and examples, and so they'll definitely be shared after the webinar today. They'll probably be on our support.dataverse.harvard.edu site, but we'll point them out when we upload them. But in general, kind of going back to the data repositories, we advise that where possible, it's important to use a discipline-specific repository. That's usually the right way to go, because they offer more specific features that are usually relevant to domain-specific data. But often those don't exist, or for research that may be highly interdisciplinary, a generalist repository like Harvard Dataverse can meet each of these characteristics and help you meet these funder sharing requirements. So one reason that the data management and repository communities have been so focused recently on the NIH requirements and policy specifically is because we do anticipate that these guidelines and best practices to kind of percolate across funders, both federally and privately. I mentioned that the NSF has recently released an updated data management policy, and that largely aligns with the work that the NIH has already produced. And we also at Harvard Dataverse work with a lot of private funders who have also implemented data planning and sharing requirements over the last several years. So if you do expect to seek funding in the future, it is likely that you will have to both prepare a data management plan of some quality that includes a few specifics on where and how you're going to share your research data. This first link at the top is a link to our data management plan guidance for Harvard Dataverse users specifically. And that's it aligns most closely to the NIH guidance right now. But most funders are going to ask for similar information about what data you're going to produce, what tools and software you use to store, manage, and analyze your data, how you're going to describe it so others know what it is, what restrictions or special considerations are required to interact with and use the data, and then generally who's responsible for managing the data for the project throughout its life cycle. So these are all pretty common elements that you will see across many of the templates for different funders for DMPs right now, and we expect that to kind of be aligned more closely, if anything. And so this slide is just to kind of help give a sense of a few other funders that do require data management plans and what elements they require you to describe. So it's kind of conceptually similar information across different funders. And the reason that is, I think, is because, and I want to emphasize that these formal data management and sharing plans are largely asking you as a researcher to describe the data management activities that you're already doing. And usually you're doing them, pretty well. So it's mostly a documentation effort with a bit of added work to kind of deposit and share your data in high quality repositories. And so similarly, kind of our efforts in the repository community are to build products that work with your research process. At the end of this webinar, one of the later slides, I have one that has a couple of links on how to leave suggestions for features and let us know kind of when you experience problems with existing ones. We're building lots of new things all the time, so we want them to be useful for how you actually work. So engaging with the community is a way that we really like to do that. All right, so for the rest of the webinar, I'm going to kind of spend some time on each sort of common element of a data management plan and give some guidance on how to implement best practices related to each element using Harvard Dataverse specifically. So the first one we'll talk about is actually, before I do that, let me check the Q&A and see if we have any questions. I don't see any yet. But if anyone has anything burning and they want to raise their hand, just want to take a second to make sure that we have time for that. Okay, I don't see any, so we will keep going. Okay, so data types. Yeah, you're always going to be expected to describe the types of data that you're going to generate or collect over the course of a project. That's a pretty typical ask in a data management plan. As part of that, you're also going to want to indicate the portions of project data that you're planning on sharing, and any data from other sources that you're acquiring. Sharing all of the data from a project is generally not required. It's reasonable to think about a subset of the full data that you might share based on maybe what is legally and ethically permitted for sharing, or what is, most commonly reusable. Subsets can include portions of the data demonstrating the principles outlined in a resulting publication, a small representative sample of de-identified data, subsets that are specifically designed and curated for replication studies, things like that. So there's a variety of different ways to curate subsets of data in a data set that will meet your funder requirements, that will meet these kind of sharing requirements that you have. It's not necessarily expected that you share every iota of data in its rawest form. That's not super usable. If we think about the FAIR principles, we want the data we share to be reusable. And so part of that is, in addition to kind of the straight data files that you publish, you'll also want to include supplementary files, such as metadata, code files, documentation files, to help users really understand the full context of data files. So we're going to follow this example over here. These slides are generally structured the same. Or these slides are generally structured the same. So you'll see kind of an overview of what the concept is, and then some examples. And so all of these links should kind of go to good examples of either data sets or kind of typical useful links that can be useful. So we'll take a look at this first example, and it's a replication data set for a survey. And the thing I kind of want to point out, we're going to look at a number of different data sets. So I'm not going to go over kind of every element of what a data set looks like right now. Sonia did that in her previous webinar. So I'm going to kind of operate on the assumption that maybe we've seen a data set on Harvard Dataverse before. But I want to kind of scroll down and focus on the files tab, since we're talking about different data types that you might upload. The way that Harvard Dataverse works is you have data files contained in this data set, and the different types of data files can include things like your data files, which is, you have an example down here, this tab file. We have some obvious supplementary files, a README here, a code book up here. This is a really wonderfully structured data set that includes lots of useful, kind of clearly described data files. One element that's kind of useful to consider, I guess before I go into this, one thing I want to mention about these data file extensions: the codebook is a PDF, the README is a TXT file, which are great best practices. Harvard Dataverse will accept any file type regardless of file extension. There is absolutely no, we're completely file agnostic, so you can upload any type of file. We do have a file limit of 2.5 gigabytes. So if you try to upload any one individual file that's larger than that, it will not work. We can raise the limit on that, but you'll have to contact us through our support email that you can find just up here at this button. The idea there is, if you're not aware, Harvard Dataverse is a completely open repository that anyone can upload any data to. So we have some file restrictions, size restrictions in place to kind of ensure that people aren't just sort of simply uploading, hundreds of 10 gigabyte files at a time. Those aren't going to be particularly reusable unless there's a good reason for them to be that big. So if you do need to upload very large files, you can contact us and we can kind of walk you through how to do that and give you the permissions to execute that. Another thing that's super useful is kind of how the data are handled are for tabular data specifically. So here we see in the metadata of the file, the data set has, or this data file has been identified as a tabular data file. So things like data that are in spreadsheets, the software can recognize and will kind of do a few things to it. It will automatically do a little bit of converting into a, not necessarily, converting maybe isn't the right word to use. It will copy that file into an open file format, so into this .tab file format. If we go to this button right here, which is access file, we'll see that the original file format is a stata file, which makes sense based on kind of how they've described their data here. These tags are user generated; they're not automatically generated, so they've indicated that that these are stata files. So for some tabular data file formats, the software will kind of read the tabular data files. It will index the variable headers. It will do this copying to open file formats so that users can download this tab file and use it as tabular data without having to import it into stata to read the file. And that's kind of a useful way to sort of make data a little bit more reusable to a broader group of people. These users have also included some code files. So the do files from their stata workflow, that's really a great practice to consider applying, is to upload the code along with the data. Usually for research data, you're doing some sort of analysis, and it's helpful to kind of include the process of that analysis in your data set. And then they also have some supplementary figures. So they've produced it. I imagine that these stata files have produced some sort of figures, kind of describing the data even more, or producing a bit of output that support the argument in their publication. And so some people also like to include these figures. I'll talk a little bit more later about all of the metadata that can go along with files. But for now, I think we can kind of see that things are described well. They've done some curating to sort of develop documentation files so that when you look at this, you can sort of see, yeah, this looks like a reasonable data set that could be used. It has all of the files I need to reuse it. And so that's a good thing to kind of take a look at. All right. Oh, one more thing I wanted to mention about this. I was just checking my notes to make sure I didn't miss anything, which I did. Another part of the ingest that happens in that tabular data ingest process for spreadsheet things is that it reads the data files and makes it possible to kind of do a preview of the data files. So we're going to sort of take a look at these. I'll talk more about what they're asking for here a little bit later. It's a guest book, so they can kind of track who's using it. So I'm just going to enter this here. And I just want to kind of take a look at these data. So I can see here that there's a number of, it gives me kind of a preview of the data, so I can sort of tell if I want to use it before downloading it. It looks like if we kind of scroll down, it looks like there might be kind of a huge number of observations. So I can kind of do a bit of evaluation before I can look at kind of at the variable headings before kind of downloading it onto my machine and opening it up with a different program. So I like this file preview. I think it gets used pretty heavily to sort of see what's inside of a file before. And we can also do that with PDFs too. So let me roll down here. I'll do it on the next example. We can move on to the next one. But it's a nice little feature to have a previewer. All right. So our next section is tools and software. So data are kind of one part, I think, as we saw, one part of the original materials used in a research project. The software and the tools used to gather and manipulate and collaborate over the data are also super important. So whatever you're using, as we saw, I think Stata, it was very helpful to know that that was what was used for that project. That was the software they used. So providing some information about the code, the scripts, the hardware, the software, and the implementation details of a study is a good way to enable full reusability. So when you're depositing data, you'll also want to consider adding some information about the devices that were used to collect the data, what software or programming language that will be used to work with the data, or that was used to work with the data, whether the tools and software are open source or free, or they're proprietary, meaning you need to purchase a license to use them. And then also kind of if you know, or if it's relevant, kind of how long the tools and software will be usable to access the data. So I've definitely been involved in projects where we've used software libraries that are a little bit out of date and maybe don't work as well anymore. No one's maintaining them any longer. So that can be useful to communicate too. You can say, this is the version of a software we use. We don't think it's going to be updated anymore. It might be being deprecated. So take that into consideration when trying to reuse this code. I'm going to pull open this example first. This is just another example of a data set. It is replication data for, it looks like a physics model. Very cool. So again, down here, if we take a look at the files, we look at the file extension and what the software has identified as what type of file it is, and that it's a Jupyter notebook, so a Python notebook. Let's see if we can go down. We got some Python source code files that are named right here. And then we've got this PDF file here. Here, I'm going to go ahead and look at this document so we can look at our preview and kind of see a bit more about what the files might be in here. So it looks like in this table of contents, I can see immediately that there's already some information about the code, some technical details about the models and methods. Pretty neat. So yeah, the first section, all experiments were performed in Jupyter Hub using the Python 3 language, version 3.10.8. This is really helpful, wonderful information to have as a reuser, especially if this is like in 5 years and maybe you've upgraded to a Python version or upgraded libraries, things like that. This is really helpful information to have. So if I go back to this, one thing I want to demo, a great kind of system integration that Dataverse has that works really nicely is in this access data set button, we have kind of another explore option. So in addition to the file previewers, we've got this integration with a product called Binder, which if you click on it, it will open up a kind of cloud computing environment that will allow you to run the files. It will preload the files and then allow it to run in that environment. And so I've actually pulled it up over here and it did load, which is really wonderful. Sometimes it takes a very long time. So basically what it looks like is I opened this, I'm clicking on Binder. It'll kind of generate in a pop-up a new window and it'll tell me that it's compiling everything. So here's kind of what it looks like. And then once it's finished kind of initializing the repository, it will open up and look like this. And so this is very cool. You can kind of pop over here to the directory. So these are the files that were in the data set. So if we look over here, we see code part 0 computational routine.ipynb, and here we see it right over here, code part 0 computational routine.ipynb. I'm going to double click on it, and then we see kind of just wonderfully exactly just a Jupyter notebook like we expected to. So I can kind of come in here, I can run these cells. It's been described very well in Markdown. So we've got some descriptions up here about how he's operated the analysis. The code is commented really beautifully. It's just a wonderful example of kind of, we can run all of these scripts without even downloading. So that's kind of a nice little tool integration to use as part of your data management strategy. Another couple of things that are maybe relevant for the tools and software section, I'm going to close that, we have a few other integrations with other commonly used tools and softwares as part of the research process. So there's a GitHub action that is linked from here where it basically describes how to implement it. You write a simple YAML file, you include it in your GitHub repository, you add things like your API token, you point it at which directory in your GitHub repository you want to upload files from, and then whatever you set it to execute on, so a common trigger is a software release. So every time you initiate a new software release at your GitHub repository, it will trigger the upload of the files from your GitHub repository into a Dataverse dataset that you've already specified. So that's a really wonderful integration if you use GitHub already. Similar ones exist for RSpace, which is like an ELN, an electronic lab notebook type of environment. And then also with OSF, really common to use. OSF is Open Science Framework is really excellent, especially for active collaboration. So if you have a group of a number of researchers across different institutions, Open Science Framework is really nice for collaborating over. And then it gives you a nice opportunity to just sort of port those files directly over to Dataverse and kind of archive them in a repository to meet kind of either your data management plan or your funder requirements or your general requirements. So those are some kind of tools that we see commonly used. If you have other, programs or systems or software or tools that you want Harvard Dataverse to interact with or Dataverse software to interact with, we're always interested in kind of keeping up with what people are using. So happy to think more about that. Oh, I see some Q&As. Oh, great. Great questions about a replication data set. I might save this and kind of talk about it a little more at the end if we have some time. But that's great. And thank you, Sherry, for adding that link to replication data sets. Yeah, they are kind of a specific way of thinking about how to reproduce or replicate findings from a publication. Okay, we will move on to metadata standards. This is kind of a pretty common and somewhat tricky to understand piece of data management plan template sometimes. So kind of basically, in addition to kind of including any metadata files that are sort of required by software to read or interpret your data file. So if we think back to that Stata example at the beginning, if you wanted to really use the Stata file exactly as it had been uploaded, you would need those do files to kind of follow what had happened. Those are metadata files that are going to be required by Stata to really understand what's happening in the data. So sometimes software might have metadata files that you would naturally include as part of a data set. But another important part of the FAIR principles is to add descriptive metadata and unique identifiers where possible. And so we use metadata to describe data sets in three primary ways in Dataverse. So we have the citation metadata, which is kind of general information that is largely applicable to most data. We call it citation metadata because a primary purpose of these fields are to make it possible for others to cite your data. So this is information like author, title, date published, very basic, very simple things, but necessary elements, easy to overlook elements of a data set. Domain-specific metadata are going to be things that you can choose to add metadata fields that are specifically relevant to your research domain. We can also create custom options for you depending on what your project needs, and I'll show you one of those in a second. And then finally, file level metadata. And this varies, pretty wildly depending on the file type, but includes options to describe data more granularly. And we'll have another webinar on file handling specifically later in this series. So that would be a good one to stay tuned for if you're interested in kind of how different files work on Dataverse. But I think it's kind of easier to see rather than explain. So I'm going to open up, I went to the second example first. And this one is from the Electoral Integrity Project, another survey that they've done. And I think they do a really excellent job at kind of describing their data very, very clearly and thoroughly. So instead of, we kind of have a couple of things that come up at first. We have a description that comes up and things like subject, keyword, and related publication. But we can always take a look at this metadata tab, and that's going to give us sort of the most complete information. Everything that's in here is searchable. So if we want to go to an advanced search function in Harvard Dataverse, each of these fields are specifically searchable. So we could look for data sets that specifically have the topic classification elections, and this would pop up pretty quickly. One thing that's really useful and helpful to do that makes your data more fair is to include persistent identifiers where possible. So things like ORCIDs are going to help disambiguate author names. So what that means is Toby S. James even. I think it could be reasonable that we might have more than one Toby S. Jameses in the world. So adding something like an ORCID, which this researcher has done, means that we're making sure that this data set is connected to this specific Toby S. James. So we really recommend, if you're a researcher, getting an ORCID, registering for one. It's free, it's just a number, but it collects all of your research together, all of your outputs together. So including things like ORCIDs is really, really wonderful and important to do. And they've also added things like their funding information IDs, other kind of rich information that really helps us kind of learn a lot about this data before even looking at the files. The description is really useful. Another one I really want to emphasize is the related publication. So most of the time, we were talking about how data sets are curated, and I don't want to be too prescriptive about this, but one very common way to organize your data and publish it is according to a publication. So oftentimes the researcher will kind of do some research, write a publication. Sometimes a data collection process and analysis will lead to a number of publications. And so for each individual publication, there will be a subset of data and a subset of analysis kind of scripts or kind of experiments that will relate to a specific publication. So that's where this really comes into play. It describes kind of a lot more about the research, obviously, and all of the outputs, all of the conclusions that were drawn, things like that. So connecting the publication is really important. And you do that by adding the citation to the related publication in your data set. And then also going back, taking a look at this citation. This is a recommended citation up here for this data set. And so we really encourage you as authors to cite your data sets in your publications. So then you have kind of this really nice closed loop where you've got the publication citing the data set and the data set citing the publication. So these things kind of remain connected kind of as they sort of enter the scholarly discussion. These things operate both as separate outputs, but kind of in a unit. So the context is always available. And then the last thing I wanted to show is that in addition to, you'll see up at the top, this citation metadata block, we also have geospatial metadata blocks and social science humanities metadata blocks. So these have a little bit more specific information. On the back end, the schema is structured a little bit differently, so that humanities and social science specific either indexers or aggregators are going to be able to understand this metadata in a more specific way. I won't go into that too much right now because we're getting towards the end of the talk. So we've got two more sections to go over. So data preservation and stewardship. This is a concept we've talked a little bit already about using those desired characteristics and the FAIR principles to choose a data repository, and definitely identifying the repository that you plan to use as part of a good data management plan. I've included a link here on this slide to our preservation policy for Harvard Dataverse, which details our commitments for keeping your data over the long term, our partnerships with the storage facilities that we use, and our backup schedule. And the other important concept to keep in mind when depositing data is what your ongoing stewardship is going to look like. So we talked a little bit about sensitive data. So one example of kind of ongoing, no, we didn't talk about sensitive data yet. Okay, good. So we will talk about sensitive data in a little bit. But one example of kind of ongoing stewardship is going to be kind of remaining available and responsive to inquiries about your data and about data access. And this is especially important when it comes to things like restricted data. So if someone wants to access something, you need to be available to make sure that that access is available if it's mediated. We have that contact creator button or contact owner. Yeah, right here at the top. That needs to go to an active email address. So stewardship concerns are also things like making sure that if you move institutions, for example, that you update that email address or that you have a plan for who's going to be responsible for or how the data will be managed kind of into the future. And then one kind of quick example I also want to talk about is this one right here, and that's about versions. So one thing to keep in mind is it's super reasonable to think that you might want to edit your data after you've published it. And so here's an example of kind of someone that's doing that, that's relying on a workflow that includes many updates. They basically kind of have created this compendium of ancient genomes, and they are adding to it over time. So as new genomes are sequenced, they add to them, or they add them to this data set. And so over time, we started with, we migrated some data from a website over to Dataverse, but so we can see all the publication dates are the same. But over time, they're going to continue updating this. And so here's kind of how the versions are tracked. Each time you update a file or add a file or remove a file, it creates a major version change. If you only changed the metadata, this would go from version 1.0 to 1.1 instead of to 2.0. We can click on kind of the view details of any summary, and this will kind of show us what existed in the previous version and what was updated in the newest version. That's on the metadata. And then in the files, it looks like these were in the previous version, and then they were removed. And then in the current version, some different ones were added. If you click on any of these older versions, it will take you back to that previous version, and you can access the files that are in that previous version. So we keep access to those available. All right, 10 more minutes. I think we can do it. This is the final section of kind of a DMP that we're going to discuss today, but it's an important one. So access and reuse requirements for your data. So here you need to be sure that you describe all restrictions related to the informed consent, privacy, relevant legal protections and policies, and any other considerations. Data by default in Harvard Dataverse are published with an open license called CC0, which is a public domain waiver. If I click on this one, we can see under this terms tab and right here that they have used CC0. In general, most open data repositories consider a permissive license like this to be the best option for data that can be publicly shared. The idea behind this is that the easier you make it for people to reuse your data and the clearer you make it that you aren't planning on suing anyone who does, the more likely it is that your data will be reused. One of the primary purposes for archiving data in a Dataverse repository is to enable that reuse. So having clear and open terms helps realize that goal. CC0 was crafted specifically to reduce any legal or technical impediments to the reuse of data. In most cases, CC0 does not actually affect the legal status of the data files themselves, since facts in and of themselves are not eligible for copyright protection in most countries. But where they are, and for files that are not data files, that are things like your code files, your documentation files, CC0 waives copyright and related rights to the extent permitted by law. But one important thing to keep in mind is that CC0 does not exempt those who reuse the data from following community norms for scholarly communication. It does not exempt researchers from using the data in a way that is mindful of its limitations. Nor does it exempt researchers from the obligation of citing the original data authors. However, like other scientific norms, these expectations are best articulated and enforced by the research community itself through processes such as peer review. But by removing unenforceable legal barriers, CC0 facilitates the discovery, reuse, and citation of research data. All right, this one I want to show you is a little bit different from the CC0 license. They have applied a custom terms of use. So if we go into this terms section again, here we see custom data set terms, and then down here we can see that they've applied like a really clear and robust kind of terms of use document. We facilitate this in a couple of different metadata fields, terms of use fields. And you can describe things in kind of any way. So really any text that you put in these is effectively applying a binding terms of use to your data set. So you can add whatever you want in here. You can have any citation requirements. You can kind of add a whole lot of information in this field to make it kind of as customizable as you need it to be. This group has also employed a feature called the guest book, which is something that grabs or requires users to disclose some information before downloading a file. So how that works for this one is that this research group has asked for emails and institutions of the downloaders before downloading the files. And then optionally, they would like you to also provide your name and position. And so these are completely customizable. You can make this, you can kind of add whatever information you want to collect in here. It can be really useful for reporting statistics. We do have kind of some data set metrics that are very simple up here. Those are being kind of added to, we're adding more features to the metrics, more statistics in the near future, but for now, it's kind of a simple download count. But the guest book is a good way to get information about your users. All right, and then finally, a quick mention about sensitive data. I'm not going to spend too much time here, although it's very important. And that's because Harvard Dataverse is not a repository that is suitable for sensitive data. You will really want to, if you really need to publish sensitive data files, there is a different repository is going to be the one for you. However, there are strategies for advertising the fact that you do have data available for access via an application process or some kind of vetting program that you have in place through a data use agreement or something like that. And we use that a lot. So here's one, the Henry A. Murray Archive is one that definitely has a lot of sensitive data in it that we manage at IQSS. Some of the ways that we handle that are by creating documentation files. So this study description PDF, the cover sheets of the boxes from the analog files that were digitized, do a lot of describing. So once you read these, you can kind of evaluate whether or not you as a researcher want to apply for access to these files. Some files can be restricted as long as they are not kind of sensitive enough to require kind of an encrypted data transfer mechanism. You can put sort of in Harvard's kind of sensitive data lingo up to level 2 data in Harvard Dataverse. But for anything level 3 or above, so anything that's actually sensitive, those files need to kind of live somewhere else. You can advertise them, you can add a lot of metadata, you can describe them very well, you can describe the contents of them, you can add documentation files, things like that to help a user know that there is the potential to access these, but they have to go through a process in order to apply for it. So that's kind of how we go through that. There's an option for restricted files, but no sensitive data files on Harvard Dataverse. All right, so we're gonna kind of wrap up just to sort of summarize. All of these activities that we just talked about are going toward making your data more fair. This slide has many of these actions and how they fall into the FAIR principles. The ones that are bolded are the actions that you, the researcher depositing data, are primarily responsible for, and the ones that are not bolded are the ones that we largely cover as a repository. So you're responsible, for example, for using the metadata fields that we provide to add specific descriptive information to your data set to make it more findable. And then we structure those fields on the back end so that search engines like Google will actually pick it up and serve it to potential users that search Google for it. We also create integrations with systems like Binder and GitHub, but it is your responsibility to add documentation and to comment your code in a way that makes it possible for other users to actually run the code that you share. So things like that are really important. And as I mentioned, kind of here's a number of ways to get involved in the community of Dataverse users or to get help with your data deposits. I want to just plug this demo server over here. Demo.dataverse.org is a great way to play around with the different features. One way to also manage access restrictions is to adjust the permissions of your data set, which we didn't really go into too much. But you can play around with those on the demo server. I would highly recommend that. That's a great place to mess around with that, because you can create like 4 different accounts and then see how each account has permissions depending on what you've given. So it's a nice sandbox to kind of test with. And then, yeah, that's it for now. I think we've got some Q&As, so I will go into those first. I think they've both been answered. Thank you, Julian and Sherry. Yeah, back to replication data sets. Yeah, the general sense is that researchers curate data sets specifically so that the figures and the outputs from a publication or an analysis package can be replicated exactly using the exact same data. There's a couple of different definitional controversies between the word replication and reproducibility and things like that. So I won't go too much into it, but it's yeah, pretty common to see the word replication data for as a type of data publication. And then, is it possible for an analyst to update and manage data on a faculty Dataverse profile? Yes, basically you have what are called collections, and then we can kind of give you that space specifically to manage your own data in there. So yeah, Julian kind of gives a sense about that first. I would recommend testing on the demo server. We don't have like public profiles on Dataverse per se. So it's more like you can create a collection and put data sets in there rather than sort of having your profile publicly available like you would on like ResearchGate or academia.edu or something like that. And then, how can I add a new metadata standard to my Dataverse installation? That is a good question. I will let Julian either unmute himself to answer that, because he's our metadata guru, especially when it comes to different installations. But yeah, go ahead, Julian.
Oh yeah, thank you. I work a lot with metadata. I wouldn't say I'm a guru, but we are planning as part of this webinar series, we'll have webinars in the future that go into more detail about how metadata works in Dataverse, and that will include information about metadata standards and adding new metadata fields and changing the way that metadata is exported from your installation, for example. I guess for now, I can I'll add a link in the chat that points to the section in the Dataverse guides about metadata customization, and that those pages include technical information about changing the metadata blocks, which is the collection of metadata fields in Dataverse. Actually, it looks like. So Katie is looking for that. Hopefully, a group search. There we go. finds it more quickly. Yeah, so if that's what you meant by adding a new metadata standard to database installation, then this is what you would do to edit the metadata blocks that ship with the Dataverse software, or to create your own metadata blocks. We probably you'd like to add metadata specifications without needing to make any changes. Right, yeah. So it depends. If you want to make changes to the metadata fields that ship with the software, then you need to make changes to the code right now. If you want to add new metadata fields, then you can do that without making changes to the code. It's easier to maintain those changes as you update Dataverse software versions.
Yeah, if you are editing the TSV files, is that right?
Exactly. Yeah.
Yeah, I would recommend going to the metadata webinar. I think that it will become clear kind of how metadata works in Dataverse, which should clarify a little bit more about why things are the way they are, which, you know, with legacy software, there's always an interesting answer to that. I know we're a little bit over time, but just to add one more comment about that is, yes, the recording will be shared on probably the same place that you found that you registered for the webinar, but we'll also link it from Harvard Dataverse, so it should be easy to find. And I think we'll probably send them out to everyone that's registered, so you should get an email with it. But yeah, one more thing to think about when it comes to metadata is we want to add metadata blocks that are useful for the software community as a whole. So other repositories also, not just Harvard Dataverse. And especially if you're using an established schema for a specific discipline, we want to make sure that it is kind of community developed, that it is in fact the correct schema for a specific discipline, or the one that is most broadly useful for the most people. So rather than having everyone just kind of make their own metadata, that kind of defeats the point of having structured metadata. So we want to kind of coordinate that effort a little bit. But yeah, it is somewhat flexible, and you can always, adjust the TSV files that you use. All right, if there are not any more questions, thanks to everyone for coming. We only went 2 minutes over, which is, we covered a lot, so I think that's a win. But I'm going to go ahead and wrap this up unless you have any more burning questions.
Hey, Katie, you might have mentioned this. Deborah asked if the recording will be shared. I know you said the slides will.
Oh yeah, I think we'll put them both in the same place, maybe. It is currently being recorded, so the intent is to share it. I think they will be sent out to everyone that registered, both the recording and the slides, and linked from the homepage or the support page. So we have not decided yet, though, exactly where they will be. All right. Thanks very much. See you next time.